Now, this time I want us to look at how we can measure the rate of reaction. So, measuring the rate of reaction. Now, to do that, we there are some experiments you'll be doing in your paper tree, which is going to help you to determine the rate of reaction. Now, one of these methods include the preparation of carbon dioxide gas. So, usually you have marble chips which contain calcium carbonate. So this is solid and you'll be reacting with hydrochloric acid aqueous, and you should have calcium chloride, and then you also have carbon dioxide gas and H2O. So this is a reaction between calcium carbonate and HCl. So the reaction setup look like this, where you have the reaction mixture. So down there you have the marble chip, and then you have the HCl. Now you need to take note that in this reaction the HCl acts as the limiting reagent. What that means is that it's going to be consumed in the reaction while we still have excess of the calcium carbonate. So that's exactly what is going to happen. This is stopped. This is stopped with let's say bang with a hole. So you have the delivery tube. So while the reaction proceeds, you are going to have carbon dioxide going out through the delivery tube, and it is connected to the gas syringe. So the volume of gas that is being produced can be measured. As the gas is being produced, it will push the plunge out of the syringe. So with time, you'll be able to measure the volume that is being um, produced as time goes on. So let's say you have a data from this. You now go ahead and plot a graph of volume of carbon dioxide against time, as you can see here on the right. So if you do that, you have this curve that increases sharply and then begins to reduce as time goes on. Now, the reason why this is increasing is that at the start of the reaction, you are going to have a lot of carbon dioxide being produced. Why? Because the solution is still concentrated with HCl. And we've talked about the effect of concentration on the rate of reaction. So at that instance, from the start of the reaction, it's going to be very fast. The rate of the reaction is going to be very fast. You have a lot of carbon dioxide being produced. And as time goes on, the HCl, which is the limiting reagent, will be getting consumed, which means that it will be decreasing in concentration. And what is the effect of decreased concentration or rate of reaction? Right, so the speed of the reaction will decrease as concentration decreases. Is that okay? So that is why this graph is looking like this. It quickly goes up until it got to the point where the HCl is completely consumed. So the concentration of HCl is is at its minimum. So you don't have any reaction taking place again. You are only left with excess calcium carbonate. All right. Now, from this graph, you should be able to calculate the rate of the reaction. So how do you do that? Now you look at the graph, you draw a tangent touching the curve through the zero axis. So a very straight tangent over here. Okay. Then you draw a straight line to touch the tangent, trace it to the time, then you also trace it to the volume. So on the vertical axis, you find the difference between the volume. So the initial volume is what is assumed to be zero. And then as time progresses, after 20 seconds, you have what? You have 20, you have 72 cm cube of the carbon dioxide being produced. So volume of CO2 is 72 cm cube. So that's the difference in the vertical axis, and then on the x-axis you have time. So delta t is going to be at 20 seconds. 20 seconds. Is that okay? So we should be able to determine the gradient of this tangent from these two values. Okay, and that is going to be so we can say the rate from this is going to be the volume of CO2 produced per unit time. So the speed here would be 72 divided by 20. Remember, this is cm cube, and this is in seconds. So what is going to be the answer to this? So let me put this in a calculator. And I will get 3.6. Get 3.6. So we'll say that the rate of this reaction, or the rate of carbon dioxide being produced, is 3.6 cm cube per second. Okay, so in every second we produce 3.6 cm cube of carbon dioxide gas. Is that okay? So that is how we measure the rate of a reaction. That is one experiment we can do to measure the rate of reaction. Now, you can also do that by weighing the reaction vessel. So in soldering, you have the beaker and everything inside it's being placed on the electronic balance. So what happens is, at regular time interval, you measure the mass of the reaction vessel and its contents. So you gather the data for a period of time, and then where you notice that the mass is becoming constant. Okay, now in that case your graph is going to look like this. So on the vertical axis you have mass, on the vertical axis, then you have time on the x-axis. So you notice that the curve is appears to be moving from the top to the down. Okay, and it is reducing as time progresses. So at the start of the reaction, you expect to have, we assume that we are not producing any, we haven't produced any carbon dioxide yet. So at the start of the reaction, the mass of the reaction vessel and its content will be at its maximum. Now, as time progresses, the mass will begin to fall. Why? Because we are losing carbon dioxide. So a part of this is not an isolated system. So the gas is being able to go off. So we measure that time with respect, we measure that mass with respect to time. And just like we did for the other graph, you draw a straight line. Draw a straight line here. This is not straight, but you know what to do. You draw a straight line here, and then you find the gradients. Okay, you find the gradients of this line. All right. So this is going to give you the rate of the reaction. Now you can also draw a tangent over somewhere over here. Okay. Now this is going to be like over a short length, but then the best tangent you can use, or what will give you the best gradients, is the one that is starting from the origin of the curve. Is that okay? So the longer the tangents, the more easier it is for you to work with the values. All right, see you in the next video.